Today's lesson, section 6.2c, is the trigonometry of right triangles. We're talking about reference angles. So let theta be an angle in standard position. The reference angle theta bar is associated with theta is the acute angle formed by the terminal side of theta and the x-axis. So using an example in all four quadrants, so in the first quadrant when we form an angle, it's actually going to be, the reference angle is actually the same as the regular angle that we usually graph. So if we get 30 degrees, the reference angle is actually 30 degrees as well. Now if we graph something in the second quadrant, then theta, being like, let's say 135 degrees, is actually different than a reference angle. So we form an angle where our line is actually closest to our x-axis. And so this over here would be theta bar. So to get that value, we take 180 minus theta. Okay, so if it was 135, we would take 180 minus 135, and that would get us 45. So our reference angle would be 45 degrees, not 135 degrees. Okay? So in quadrant 3, we would be doing kind of the same thing, except in order to get this angle theta, so here, let me put it in a different color. So in the green would be our theta bar, and the red would be theta. So we could say that that's like 210. So in that case, if I was looking at 210, my reference angle would actually be 30. So in order to get that, you would actually take kind of the same subtraction property as the second quadrant, but you'd reverse it. So it would be theta minus 180. The reason why it switched around is because now your angle for the third quadrant is actually bigger than 180, so you would subtract 180 so you wouldn't get a negative angle in that scenario. Okay, and then the fourth quadrant, you go all the way around, so it could be like 300 or something like that. Okay, so then come in the other direction would be our theta bar. And so if it was 300, then our reference angle would actually be 60. So to get that, it's more similar to second quadrant. So we take 360 minus our angle theta. Okay, so then that's kind of how you get the reference angles. Now you're always subtracting so that you get a value in between 0 and 90. That's always our goal. Okay, and so those are the operations that we need to use to be able to do that. So just to add to this, in the quadrants, certain trig functions are positive and some are negative. So in the first quadrant, all functions are positive, just because of how it's set up, because x and y are both positive in that quadrant, so all functions end up being positive. Okay. In the second quadrant, just sine and cosecant are positive. All other functions are going to be negative in that case, because your x value is negative and then your y value is positive. So that's why sine and cosecant, because they're reciprocals of the y value, that's why they're positive and the other ones are not. In the third quadrant, tangent and cotangent are positive, because everything is negative. Tangent and cotangent are the only ones that take the value of your x and your y at the same time and then divide them. So negative divided by a negative makes a positive in that case. And then the last one, in the fourth quadrant, your cosine and your secant are positive, because x is positive here, and those are the ones that are dealing with just x and not y. Okay, so one way to remember this is taking the first letter, and I kind of underlined them as I went, but I'll circle them as well. So A, S, T, C if you went in a counterclockwise fashion. So it's all students take calculus is the acronym that we use, but You can use whatever you want to help you remember that, but just remember the signs of your x and y values, and that kind of makes it helpful later down the road. Okay, example 3, we want to be able to find reference angles given a particular angle. So if I'm given 7 pi over 4, that is in the third quadrant because it's greater than pi, because it's pi would be 4 pi over 4, and then 3 pi over 2 is still smaller than 7 pi over 4 because it would be like 6 pi over 4. So that lands in the third quadrant. So if I want to find my reference angle, so then I take 360. In this case, actually, it would be 2 pi because we're in radians, so 2 pi minus 7 pi over 4. So then that would be the same thing as 8 pi over 4 minus 7 pi over 4. So that would get me the value of pi over 4. Okay. And then here I have 750. Now sometimes you need to subtract 360 or 2 pi from it to get a value that's in between 0 and 2 pi before you can find a reference angle. So if I take 750 minus 360, that gets me 390. And then 390, once again minus 360, because I'm still not in between 0 and 360. That gets me 30. Well, that one's easy because it actually lands in the first quadrant. So 30 degrees would be your answer because it's, remember that the first quadrant, the reference angle is the same as your regular angle. So all it did was go around twice and then land there. We were just taking the 360 off so we could figure that out. Now I want to be able to find certain trig functions using my reference angles. So let's say I wanted to find sine of 510. So first I would subtract 360 from 510. So I'll still have sine here, but then that gives me a sine of 150. Now if I don't know the value of 150 right off the top of my head, that's why reference angles are nice. So if I go here, 150 is actually greater than 90 but less than 180. So then my reference angle would be 180 minus 150 because I land in the second quadrant. Okay, and that gives me a value of 30. So then really, I'm looking at sine of 30. Okay, and so then sine of 30 I know is 1/2. Now the reason why I showed you the positive trig functions is because I have sine here. I need to check whether it's positive or negative in that quadrant. And so sine is positive in the second quadrant, so that means it's no change from the 1/2 that's in the first quadrant. Okay? So then 1/2 is my answer. Now let's look at cosecant of negative pi over 4. So same thing here, it's less than 0 and 2 pi, so then I need to add 7 pi, or sorry, add 8 pi over 4. Which remember is the same thing as 2 pi. I just need to make common denominators to do so. So that gives me 7 pi over 4. Okay, so I'm still looking for the cosecant of this. So we already talked about that being in the fourth quadrant. So if I want to find the cosecant, remember that's the reciprocal of your sine. So using your reference angles, 8 pi over 4, which is the same thing as 2 pi, minus 7 pi over 4 gives me pi over 4. So now cosecant of pi over 4 is what I'm looking for. And so sine, or pi over 4, remember their point is square root of 2 over 2 comma square root of 2 over 2 in the first quadrant up here. Okay, and so cosecant would be 1 over that. So then I'd flip it. It gives me 2 over square root of 2. And now because you're in the fourth quadrant, that means that sine is negative in that area. So then my final answer should be a negative 2 over square root of 2, because sine and cosecant are negative in that area. Now, last thing I want to talk about is the values of our unit circle. So, in class, I can show this again if you'd like, because it's kind of hard to explain this in a video, but using the unit circle values that I already know, so like I said in class, before, when we talked about this, I don't have the entire thing memorized. I just know particular parts and then relationships between the values. So I told you that I knew sine of 30 degrees was 1/2. Okay? So then that means that I always know that 1/2 and square root of 3 go together. So then the cosine of 30 degrees should be square root of 3 over 2. Okay? And so then now, on the opposite side of my first quadrant, 60 degrees, it's going to be the flip of that. And they're always the flip. So the 30s and the 60s of each one is always going to be the reciprocals of each other. So they kind of switch spots because they are 1-to-1 almost, in the same sense that you flip the x and the y's. And then 45s always have the square root of 2 over 2 values that come up. Okay? And so now I can just do this by reflections. So 120 would be the reflection of 60. But now, since you're in the second quadrant, your x is negative, but y is still positive. Okay? And I can do the same thing. 120 is the flip of 240, but you're in the third quadrant, so everything's negative. And then 300 is the flip or the reflection of 240. But now x is positive and y is still negative. Okay? And I can do that with everything. So now the 45s are all the same. You just have to change the signs depending on what quadrant you're in. Okay? And then my 30s are flips of each other, so then I get negative square root of 3 over 2 and 1/2, and then negative square root of 3 over 2, negative 1/2, and then square root of 3 over 2 and negative 1/2. And so now, when you're on the ends, I missed one. Oh, I put something in the wrong spot. That's my bad. Let me try that again. Okay, so now on the ends, so like 0, 360, 90, 180, and 270, you're at the edge of the circles, so you have the full radius there. So at 0, it'd be like 1, 0, and then the opposite side, it'd be the reflection of that, so negative 1, 0, and then 90 is where y is all the way up, so you get 0, 1, and then 270 would be the reflection of that, so it would be 0, negative 1/2. So here I filled in my unit circle with only one fact, and I know that square root of 3 over 2 and 1/2 go together. My 45s are always square root of 2 over 2s. And then the right angles, so to speak, or the ends of my circle are always going to have a value of 1 and a value of 0. Okay? Have fun.